All right. Here we go. Here's another review video on um, the scale factors and how they're affected, how they affect area of certain shapes. Okay, so we went over this material in Unit 4 and Unit 5. I just wanted to kind of look more closely into it with this worksheet. I'm not going to do every question. I'm just going to do some of them, and then I'm expecting you to be able to do the rest, okay? All right, so it says here, when any solid is dilated using a scale factor of k, all blank are multiplied by blank, and all blank are multiplied by blank. Okay, so here I'm expecting you to know that all dimensions, let's see, all the dimensions or side lengths are multiplied by the scale factor k, and all of the areas are multiplied by k squared, right? Because when you're dealing with area, it's two-dimensional, so you have to multiply k 2 times. So what was the formula we used to solve for the area of a dilated figure? We said the area of the image is going to be equal to k squared times the area of the pre-image. Okay, so let's use that formula in some of these problems. I'm gonna skip number 2. I'm gonna do number 3 because number 3, if I do number 3, you should be able to do number 2. So it says here, the triangle has the area of 24 square inches. Calculate the area of the image if the original triangle is dilated by these scale factors. So again, I'm just going to go ahead and use this formula up here, right? So the area, and I'm going to start abbreviating. IM is image of k squared times area of pre-image, right? Or maybe I'll just abbreviate I as image and P as pre-image. Okay, so the area of the image is going to be k squared, which is 3 over 5 squared, times 24. 24 square inches, so that's going to be inches squared, like that. Sorry, I'm a little nasally right now. I'm recording this in the morning. Okay, and then when you're squaring a fraction, right, you have to square both the numerator and the denominator. So that's 9 over 25 times 24. 24 gets multiplied to the 9. So that's going to be, let's see, 216 over 25. I would like for you to just go ahead and get the decimal. You should get 8.64 inches squared, okay? All right, let's keep going. Number 2 is very similar. I'm going to post the answer key on Schoology so you can look for that as well, okay? All right, so what about this one? The trapezoid has an area of 100 square units. What scale factor would be required to dilate the trapezoid to have each area? So now we're kind of going backwards, right? We're going a little backwards. We're trying to find a scale factor this time. So I'm going to use the same formula. I'll do number 5 again, and you're going to do number 4 on your own. So area of the image is equal to k squared times the area of the pre-image. Okay, I is image, and then P is pre-image. Okay. We have the area of the image. It says the area of the image is 4 here. And then it says the area of the pre-image is 100, and this is the area of the image. Okay. So I would need to solve for k here, right? So what I'm gonna do is I'm just gonna practice like getting k by itself. I know I have to divide both sides by the area of the pre-image. That cancels out, that cancels out. So we get this. Right? And if I'm solving for k, I need to square root both sides. That cancels out. So basically, I'm going to rewrite it here. K is going to be equal to the square root of the area of the image over the area of the pre-image. Okay, and now that I have my formula rearranged, let's go ahead and plug my values in. Right, the area of the image was 4 square units. I'm not going to put the units on this. And then the area of the pre-image was 100. Right? And then square root of 4 divided by 100. You can do this in 2 ways. I just want to show you, like if you just plug this in your calculator, you'll get the answer. But I want to show you that when you're simplifying, right, you can actually break up the square root. Oops. Okay, and then square root of 4 is 2. Square root of 100 is 10. 2 divided by 10, that's also the same thing as 1 over 5. So that should be 0.2 is your answer. Okay. So the scale factor here, what do we calculate? We're basically saying how did the area of the trapezoid go from 100 square units to 4 square units? It's because the scale factor was k. The scale factor k was 0.2. Right, 0.2 squared is 0.04. So yeah, 100 times 0.04 is 4. Okay, try it out with number 4. Try it out with number 4. Okay, let's look at this. The right triangle is dilated by a scale factor of 4. Find the area of the right triangle and the area of the dilated right triangle. Again, bunch of different ways to approach this. I'm just going to show you one way, and if you figure out a different way, perfect, that's fine. I'm going to ask you to do number 7 on your own. So, how do you find the area of a triangle? 1/2 times base times height. Okay, 1/2 times base times height. When we look at our triangle, so we would have to find the area of both of these, right? This is the height, and this is the base. Okay, the hypotenuse 20. That's not gonna be used in the area formula. So right away, I know that the area here is going to be 12. Right, 12 is the base, 16 is the height. 1/2 times 12, that's 6. 6 times 16, that's 96. So this is going to be 96. Okay. How do I find the area of the bigger triangle? How do I find the area of the bigger triangle here? You could go ahead and use kind of what we remember from previous units, right? If we have a dilated triangle, the triangles are similar. So that means, right, we know the scale factor is 4. So we could just go ahead and do this, right? 12 times 4, that's 48. 16 times 4, that's 64. And then we have the, the base and the height of this triangle, and then use that to find the area of the bigger triangle, the dilated triangle. But I want to use I want to show you that you can use this formula as well. You can use this formula. Okay, I want to show you how to use this one. So we have the scale factor. Oops, it's 4. So let's go ahead and use that. So area of the image is equal to the scale factor squared times the area of the pre-image. So the scale factor is 4 squared. The area of the pre-image is 96. So that should be 16 times 96. What is that? 16 times 96. That's going to be 1,536. Okay? That's it. Let's keep going. Okay. And then try out number 7. Same steps. Okay. This is where it gets a little bit different. I'm only going to do 1, and then you're going to try 9 and 10. So let me try number 8. So rectangle L and M are similar. If the area of L is 32, what is the area of M? Right? Do we have the scale factor here? No. Right? So that's where it gets a little tricky. Scale factor. Where is our scale factor? Right? How do you find the scale factor between two similar figures? Again, this is stuff that we learned previously. So we just have to remember that the scale factor was the image over the pre-image. Right? You pick a side from the image and you have to pick a corresponding side, a matching side from the pre-image. And then we're going to use that as our scale factor, right? The ratio of sides. So between these two, now you got to ask yourself which one's the image, which one's the pre-image. If you said this is the image, good job. And this one's a pre-image. Because we're trying to find the area of this one. We don't know the area. So that's going to be our image. It went from the big rectangle to the smaller one. Okay. So I'm going to rewrite our formula. The area of the image is equal to k squared times the area of the pre-image. But again, k, the scale factor is also k, right? But we know that the scale factor can be rewritten as a ratio of sides. So I'm going to rewrite this. Okay, I'm going to rewrite this. I'm going to say A, the area of the image is basically the image over pre-image squared times the area of the pre-image. Okay? So now I rewrote that. So now I have everything I need. Let's go ahead and plug in my values. I want a side from the image, which is going to be 3.6. I want a side from the pre-image, which is going to be the matching side 8. And then I know the area of the pre-image is right there as well. Okay. Actually, I don't want to use green. I'm going to use the same color. And I know the area is 32. So let's plug that in. 3.6 divided by 8 squared times 32. Okay. And then, I'm just going to plug all of this in the calculator. 3.6 divided by 8 squared times 32. The area of the image is going to be 6.48. 6.48. Okay. Cool. Try out 9 and 10. Same steps. You're using this part of the formula. Okay, you're using that part. Or that version, I guess. Because again, you don't have the scale factor, so you have to find the scale factor on your own this time. All right, next. 9 and 10 are very similar. Okay. So, what about this one? Let's recall what a scale factor and proportion means from Unit 3. Considering the definition of scale factor, which we just talked about right now, how can we rewrite the previous formula as a proportion? Some new words here. So we talked about scale factor, proportion. What can we do with this previous rewritten version of the formula? Okay. So we know, again, scale factor is image over pre-image, right? The K. So if I know that the formula is this, and then I go ahead and rewrite my scale factor K to look like this, right? It's the same thing. By the way, it's the same thing. Now, how do I rewrite this as a proportion? Proportion means two fractions that are equal to each other, right? So I want two fractions that are equal to each other here. And I'm just going to divide both sides by the area of the pre-image. That cancels out, that cancels out. Okay, and what happens? Basically, the rewritten version is going to look like this. The area of the image over the area of the pre-image is equal to any side from the image over a side from the pre-image. And then there's one more thing, right? You have to square the sides. Okay, you have to square the sides. So now you get this kind of like proportion. We're basically comparing the ratio of the areas to the ratio of the sides, corresponding sides. And we have to square the ratio of the corresponding sides because area is already squared, right? The units in area it's like feet squared, inches squared, centimeters squared. The sides, the dimensions aren't squared, they're one dimensional. Like it's gonna be like the length and the width. The length is like in feet. That's not feet squared. Okay, so because these are one dimensional, you have to square it in order for it to be equal to the ratio of areas. So what can we do with this? We can compare the relationship of the ratios, areas, and corresponding sides. Okay, so now this new version of the formula kind of lets us solve new types of problems. Okay, so this is where you kind of have to see there are a bunch of different ways to use one formula. You're not always going to use it one way. That's the cool part about math. You can kind of tweak it and adjust it a little bit to what you need from it. Okay, the formula doesn't tell you how to use it. The formula is there, and you could use it too, however you need to. So I'll do a couple of these. I'll just do one more. Right, the challenge question. I want you to try to. It's a challenge question, right? I want you to figure it out on your own. I'll throw the answer key up on Schoology, but again, it's a challenge question for a reason. So, okay, the figures below are similar. The labeled sides are corresponding. What is the ratio of the area of the smaller rectangle to the area of the larger rectangle? So our ratio, we want our ratio to be small rectangle over large rectangle. Okay, so I know we've been doing like image over pre-image, but they want the ratio specifically to be smaller rectangle over bigger rectangle, the larger one. So I'm gonna make sure I like adjust it to that. Okay, so we're gonna say the area. What is the new one? Okay, it's up here. Right, I'm gonna use this new one. So instead of I'm gonna say small because I want the ratio of the small rectangle on top, and then instead of P, I'm gonna say large. Okay, because I want the ratio of the large rectangle on the bottom. So the area of the small rectangle over the area of the large rectangle is equal to, right? I'm gonna pick a side from the small rectangle, and then I'm going to pick the matching side from the larger rectangle squared. Okay, so it's the same thing as this in yellow. I just changed some of the words because I want to make sure it matches my directions. They want the ratio of it, right? They want the ratio. This is my ratio of the areas. And so, okay, that's all I need to do. Let's just plug in the signs. I know a matching small sign. A small side is, let's see, I know one small side is 2. I know one big side is 6. So I'm going to go ahead and put 2 over 6. Don't forget the squared. Right, again, if you're wondering where I got those values, I'm highlighting them for you right now. Okay. And I'm gonna do my best to just simplify as much as I can. Right? So 2 squared, that's 4. 6 squared, that's 36. 4 over 36, that's 1 over 9. Okay. 1 over 9, if you want to write that as a decimal, that's going to be like 0.111, and it keeps on going. Okay, so I'll accept that I did one of these. Okay, I'm going to stop here, but 13 is very similar. 14 and 15 are challenge questions. I want you to be able to figure it out, but you're using the same formula. Okay? All right, that's it from me. Hopefully this video helped. Bye-bye.